Equations of straight lines. An equation for a line L is one that is satisfied by coordinates xy that lie on the line. It follows that if we have coordinates that do not lie on the line L, then they will not satisfy the equation for line L. Consider this diagram. Line L has been sketched through 2 points A and B. A has coordinates 1, 1, B has coordinates 4, 3. In this case, line L goes through 2 points A and B which are known. However, this line L goes through other points. For example, there's a point here, call it 3, 2, and of course there are several other points. Apart from sketching this line through this point, the question is there any other way of describing this line? And the answer is yes. We can describe this line using an equation or with an equation. So, whatever equation we come out with, say y equal to whatever, and we call that equation the equation of this straight line. The condition is this: for such an equation to be the equation of this line L, the points A and B and any other point on line L must satisfy the equation y equal to whatever it is. How points A and B satisfy the equation is what we shall look at a little bit later. So one of such equations is what we refer to as the point slope form. The point slope form. Now, to write an equation for line L, it is enough to know the slope or gradient of this line. With the slope, let's call the slope m of the line, and the coordinate x1, y1, that is of point P1 on the line. So we are saying that for point slope form equation of a straight line, we require just two things. One, we require to know the slope of the line m, and two, we require just a point P1, x1, y1 on the straight line. Now, if pxy is any other point on that line, any other point which we do not know, but the point pxy is on the line, then with these 2 points, it is possible to calculate our slope or gradient. And what is slope? Our slope, m, is equal to y2 minus y1 over x2 minus what? x1. So, y2, in this case, is y1, y2. So, our y2 here is y minus our y1 is y1 divided by our x2 here is x minus our x1 is x1. So we have m equal to y minus y1 divided by x minus x1. If we cross multiply here, we have the following. We have m into x minus x1 is equal to y minus y1. If we take the term on the right to the left, we have y minus y1 equal to m into x minus x1. This equation just obtained is what we refer to as the point slope form equation of a straight line. Looking at this equation carefully, you observe that x1, y1 are the coordinates of the point which we know on the line, and m is the slope of the line. That is to say that in order to apply the point slope form of equation of a line, all we require to know is the slope of the line as well as just 1 point on that line. Write the point slope equation of the line passing through the point 2, 5 with slope 3. And of course, for point slope equation, all we require is just 1 point and the slope of the line. Now, the point 2, 5 means x1 is 2 and y1 is 5. I am given the slope m as 3. Now the point slope equation which we just derived is y minus y1 equal to m into x minus x1. So this gives us y minus y1 is 5 equal m, the slope is 3, into x minus x1 is 2. So if we open up the bracket, we have y minus 5 equal to 3x minus 6. I call this equation 1. So equation 1 you see here is the point slope equation of the straight line that goes to the points 2, 5 with slope 3. And that is it. If we, however, simplify equation 1 further by making y the subject of the equation, we get another form of equation of a straight line, which we call the slope-intercept form, as follows. So we have here y equal to 3x minus 6 minus 5 to the right becomes plus 5. So y equal to 3x minus 6 plus 5 is minus 1. I call this equation 2. Equation 2 is another type of equation or another form of equation of a straight line, which is referred to as the slope-intercept equation. So this is y equal to mx plus b, and we call this the slope-intercept equation. Now let us relate this equation to 2. M is a slope, and the slope was given to us as 3. And then b here is called the y-intercept, of the line. And now what does that mean? If you sketch your line, for example, this point here, the point there, call it B, where the straight line cuts across the y-axis is what is referred to as the y-intercept of the line. So this form takes care of, so in this form we have the slope and the y-intercept of the line. What do you observe here? We observe, however, that we got the slope-intercept form from the point-slope form by just rearranging the terms of the point-slope form, and it gives us the slope-intercept form. We had said earlier that if this either 1 or 2 is a true equation of our straight line, we said that the point that lies on that line, or the points that lie on that line, must satisfy such an equation. In this problem, we are given just a point, 2, 5, that lies on the line. So we use these 2 points to check if the equations we have obtained, either 1 or 2, is a correct equation for the line. So let us use 2 for simplicity. So 2 says y equal 3x minus 1. The point we are given is 2 and 5, 2, 5. If this is a true equation for the straight line, then when we substitute the value x equals to 2 into this equation, we should be able to get the y coordinate of what? 5. And on the other hand, if we plug in the y coordinate, which is 5, into the equation, we should be able to get what? The x coordinate. So let us see. So if we put in 2, put x equal to 2 into this equation, what do we get? We get y equal to 3 times 2 minus 1. And that gives us 3 times 2 is 6 minus 1 equals to what? 5. So we observe that when we plug in the x coordinate, which is 2, into the equation of the straight line, we get 5, which is the y coordinate. Also, if we plug in the y coordinate, which is 5, what do we get? We have 5 equal 3x minus 1. So we have 5 plus 1 equal to 3x. So that 6 is equal to 3x and x is equal to what? 2. We see again that when we plug in the value, the y value of the point into the equation of the straight line, we get the x coordinate. So this is what we mean when we say that the point must satisfy the equation of the straight line. So if this straight line passes through 1000 points, 2 points, 4 points, as many points as possible, then each of the points must satisfy this equation, just as we have described here. In our next class, we shall take on more examples on this.